Good morning, everybody. Thank you for joining us today. My name is Ronaldo Pinto. I'm the Technical Sales Director for AFT Technology. My email is ronaldopinto@aft.com, and I'll be hosting today's webinar titled Sizing Your PHY System with Multiple K Factors. If you have any questions during the webinar, please type them in the GoToWebinar chat room. And at the end of the webinar, we have a session of questions and answer, and I'll try to answer all your questions. If we don't have time, you'll receive an email with an answer to your questions that were not answered. Let's go through the agenda that we're going to cover today in today's webinar. First, we have an introduction of the purpose of this webinar. Then we'll have a session of the definitions of the concepts and that we'll be using during the webinar. And then I'll be describing two methods of calculating firefighting system with different K factors, one with minimum flow and another one method with the same minimum flow. And as I mentioned before, we'll have a session of questions and answer that I'll try to answer the questions that you might have. In previous webinars, we have presented the case on how to find a remote nozzle and how to create an FPA report in a sprinkler system. Using as an example from the NFPA 15, figure B.2a. In this webinar, we will not be showing how to create an NFPA report. If you need it, if you want to review this webinar, please send us an email and we'll send you a link so you can review it. Here's an image of the model used in this webinar. There was a pump and we were flooding this area with this group of sprinklers. So the purpose of this system was to find the remote nozzle, size the pump, and create an NFPA report. In this model, all the sprinklers had the same K factor. But what happens when you have a different K factors in your sprinklers? In this presentation, as I mentioned before, we'll be showing two methods on how to size your pump and how to locate the remote nozzle when you are designing a firefighting system with sprinklers with different K factors. So let's go to some definitions we'll be using during the webinar. GSC, the acronym GSC stands for Goal C Control. It is a module, available for AFT Fathom and AFT Arrow that saves you the manual iteration. It iterates for you with the purpose of quickly finding the input values necessary to meet the hydraulic requirements of your system. If any of the listeners is interested in a trial of GSC, please send them an email and we can activate a license for you so you can try it for free. Another powerful feature that we'll be using during this presentation is groups. You can have groups of pipes and junctions that can be named for recall, for later recall. The easiest way to create a group is as follows. First, select in the workspace the pipes and junctions you want in the group. From the Edit menu toolbar, choose Groups and then Create. You will be prompted a name for the group. We suggest you use a meaningful name that is easy for you to know the purpose of that group. And when you select type the name, you just hit OK. When you hit OK, the group manager then opens. The selection of pipe and junctions in the group will match those currently selected in the workspace. And if you want to modify the selection further on, you can do it here. So let me bring an example of how to create a group. Okay, so We want to create a group of sprinklers. So the first step is to select the group of elements you want. It selected everything. We're only interested in the sprinklers. So you come to Edit, you go select Groups, and select Create. As we said, try to use a meaningful value. So I'll call them sprinklers. Area 1. You hit OK. And here you will see that all the elements selected in the workspace are shown here. But we don't want the pipe, and we don't want all the junctions that were selected. We only want the sprinkler. So we select none here because we don't want, and we don't want all the junctions. So we select none, and we hit Special. Now we tell them, okay, from the workspace that you selected, I want the junction types, only the junctions of the sprinklers. And now you type select junctions. Now you'll see that all the spray discharge, all the sprinklers are selected. We say okay. We say okay. Now let's check that all the elements, all the sprinklers were selected to make sure that the group has all of them that we want. So to do this, we go to Edit again. We go to Groups, and we say Select. What do we want to select? There's the sprinklers that we name. I misspelled it, sorry. And you say Select. And you will see that now all the sprinklers are selected as we wanted. So as I said, this is a very powerful tool. You can edit properties of all the sprinklers. And if you selected the pipes, you can select all the properties of the pipes and so on. Another concept that we'll be using is a remote nozzle. The remote nozzle is a hydraulically most remote sprinkler used to set up the minimum pressure required at the pump for a specific deluge area. Why is it important to locate the remote nozzle? Well, because the NFPA report for a contingency in an area is based on the remote nozzle. And what is the philosophy of this? Well, if you meet the requirements of the minimum flow and the minimum pressure for the remote nozzle, the rest of the sprinklers in that group will have higher flow and higher pressure. So you size your pump to meet the requirements based on the remote nozzle. Okay, so now let's start with the first method. Here we have a sprinkler model with different K factors. What do we have here? We have a pump pumping to a group of sprinklers, 3 sprinklers. The system has 2 groups of sprinklers, one with the K factor of 2 with the K factor of 5, located in junction J4 and junction J5, and another one, a sprinkler with a K factor of 10, located in junction 6. The goal is to achieve a minimum of 25 gallons per minute for nozzles with a K factor of 5, and a minimum of 50 gallons per minute for nozzles with a K factor of 10. So let's start by sizing the pump. First, we create 2 groups. One group of sprinklers with a K factor of 5 and one with the K group with a K factor of 10. So we would have 2 sprinklers in this group and 1 sprinkler in this group. We activate the GSC module, the Goal Seeker Control. We go to Goal Seeker Control Manager and we create the variables. What will be the variable in this case? Well, it would be the pump. The pump that is located in junction 1, and we will vary the pressure, or the GSC will vary the pressure for achieving the goals in the system, the requirements in the system. The goals in the system would be the requirement for the nozzles K5, a K factor of 5, with the minimum of 25 gallons per minute, and the goals for the sprinklers located in group with the K factor of 10, a requirement of 50 gallons per minute. So I'm going to bring AFT Fathom to show this first step. So first, we create the groups. As I said, we go to edit. We already created them. So I'm going to show you manage. We created here a group. It has 1 sprinkler with a K factor of 10 located in junction 10 in junction 6. And we have 2 sprinklers and located in junction 4 and junction 5. As I said, they were already created. The next step is to activate the GSC module. So in analysis, you go to Goal Seeker Control and you tell use it. If you choose ignore, it will not iterate for you. The next step is to go to Goal Seeker Control and create the variables. So we go to analysis, Goal Seeker Control, analysis setup. And first we create the variables. As I said, the variable would be the pressure in the pump, and the goals would be the group of sprinklers belonging to, with a K factor of 5, we require 25 gallons per minute for that group. And the group of the sprinklers located in the group K10, which would be 1, where we require 50 gallons per minute. Hit OK. Since you have 2 variables and 2 goals, and 2 group goals, sometimes it's hard for the solver to land on the best solution since there's not enough independent variables. So we will see that Goal Seeker will not be able to reach the minimum flow required for group 5 of the sprinklers. It will give us 25, and it will give us a warning telling us that for group K5, it couldn't find a minimum goal of 25 gallons per minute. It reached 24.48. So let's show that. We created the variables, we run the model. We go to output, and it gives us a warning that the goal seek control may not be valid because it reached a value of 24 when you require 25. This can also be seen in the tab of the variables, of the goals. We saw that the requirement was 25, and what the goal seeker control found for you was 24.48. To solve this problem, we need to apply a more advanced technique of weighting the goals. Since you have two goals where one group has two sprinklers, and that is the one that is not being achieved, we need to give more weight to that group. To do this, we go to analysis setup and select goal seek and control manager numerical control. This will open weighting factors for and we activate the weighting factors for the goals. Then the goal tab there will have a new column, and we can specify a group factor or temp for group K5 group. So here we would specify a temp factor of for this group K5, which has a requirement 25 gallons per minute. So let's do this. First, we go to Tool, we go to Analysis Setup, we go to Numerical Control, and we activate User Specifier Weighting Factor. Once we do this, then the variables, the goals, we have the weighting factor column will be activated. So we'll put 10 now. We hit OK. And we're ready to run the model. We go to output, and we still see that it's a little bit closer, 24 what GSE reached, but still it's not the 25 gallons per minute that we require. So as I said, a factor of 10 will get us closer, but not enough. With use 100, it will get us even closer. And if we use 1,000, we'll get right on the spot of 25 gallons per minute. So let's do it again. Let's go. So we go to Analysis, Goal Seek Control, Analysis Setup, and we increase the weighting factor to 100. Let's see what happens. We run it again. We go to output. We go to just see variables. Go to just see values. And we see with the weight factor of 100, it almost reached there, 25 gallons per minute. And GSC value is reaching 24.98. This might be enough, but let's say we're not satisfied with that. So we go through the procedure and we're going to use 1,000. We increase it again to 1,000. We hit OK. We run it. we go to output, we go to variables, goals, and we see that all the goals are met by GSC. 25 gallons per minute for this group of 25, and 50 gallons it went above it. So both groups meet the minimum value required by the system. So that puts in a pump that requires a pressure of 102.9 PSI for the size of your pump. Now, we can see the size of the pump to meet the requirements of 25 gallons per minute for K5 nozzles and 50 gallons per minute for K. As I mentioned before, we require a pump of 102 PSI, 0.9 PSI to meet the requirements of the system. So now the next step is to find the remote nozzle. Using the design alerts from the tool menu, we create two design alerts and we name it. The first design alert would be for the spray minimum 25 gallons per minute, which would be applied to the pipes leading to the sprinklers in the K5 group, which would be pipe 4 and pipe 3. And a second group would have a minimum flow requirement of 50 gallons per minute in the design alert, which would be applied to the pipes leading to the sprinklers in the K10 group, which would be pipe 5. So here we have the two design alerts. One for group K5 would be applied of 25 gallons per minute minimum flow rate minimum, and it would be applied to pipe 3 and pipe 4. And the second group would have a design alert of a minimum of 50 gallons per minute, which would be applied to pipe 5. So let's show that. We have the model. We come to tools. We come to design alerts. And we already created the design alerts. Okay. Okay, let me show this. Go down to tools, design alert. So we have two groups of design alerts. First group would be a minimum flow required of 25 gallons per minute that would be applied for pipe 3 and pipe 4. And second group with the flow requirement, minimum flow volumetric flow rate of 50 gallons per minute, which would be applied to the pipe 5 leading to the K10 group. Hit OK. Now we turn off GSC, which we do at goal C control. We hit ignore. We set the inlet pressure really fairly low. It's 75 PSA. GSC in the previous, when we were sizing the pump, found a pump that requires 102. So this will have a deficit on purpose. So we want to see which value has the highest deficit, and that will be the remote nozzle. So once we run it, we will see that which one has the highest deficit to determine the remote nozzle. So the remote nozzle in the sprinkler would be the one connected to pipe 5, G6, because it has the highest deficit. So let's do that. First, we turn off GSC. So it's turned off because it says ignore. Then we set the pressure fairly low to create a deficit on purpose. So here we have a pump that has 75 PSI of pressure, which is below the required by the system. That is, we calculated by the GSE when we sized the pump was 102.2 PSI. We're ready, so we run the system. We go to output, and we see the deficit. So for this group, we have a requirement of 25 gallons per minute, and the deficit would be 25 minus 19.74 would be around 5.26 deficit on volumetric flow. And for this group, we require 50. 50 minus 42.14 will be around 7.86 gallons per minute. So this one has the highest deficit. So this is the remote nozzle that is located in pipe 5. If we go here, pipe 5 is here. So the remote nozzle would be this one here. So now we have sized the pump, we have located the remote nozzle. Now you're ready to create your an FEA report using AFT Fathom, which, as I said, we're not going to cover during this webinar. So now let's talk about the second method. We need to calculate a system where multiple K factor exists. The system has two areas, with one with a K factor of 32 and one with a K factor of 38. So here the two areas, this is a group of sprinklers. This group of sprinklers have a K factor of 38. This would be area 2. And a second area with a K factor of 32, it would be this group of sprinklers here. The goal is to achieve a minimum pressure of 1.4 bar G and a minimum flow of 37.87 at the remote nozzle. So first, let's find the remote nozzle. We turn off GSC, selecting ignore from the analysis menu. Set the pump pressure at an arbitrary value of 6 bar, any pressure you want to set up. We run the model and go to output. We go to the sprays, tab sprays, and we look at this P static in column. We sort it in ascending order by right-clicking on the header and the select sort. This shows that junction 51 would be the remote nozzle since it has the lowest pressure connecting to pipe 10. So let's see this. Here we have a model. This would be area 1. with a K factor of 32, and this would be area 2 with a K factor of sprinklers with a K factor of 38. So our first step is to come over here and turn off GSC. So we tell it to ignore. The second task is to set the pump pressure at an arbitrary value of 6 bar. It can be any bar. It could be 6.4. So the pump is located right here at junction 707. We set the pressure at 6 bar. As I said, any value is okay. We run the model. We go to the output, and then we go to the spray the start tab. And we sort the P-static in ascending mode. So to do this, we right click here on the P-static, we say sort, we say ascending, and now we can find the remote nozzle for this. So we can see now that the lowest pressure is located in the spray discharge 51 in the model. So let's see which one it is. So to find the remote nozzle that the program detected, we come here, we look, we search for junction 51. And we tell it to find it. So here's junction, the remote nozzle. And we can see that the connecting pipe for this remote nozzle is the pipe 80. It's important for this because we're going to use a pipe that connects to the sprinkler to size our pump. So as we can see, junction 51 would be the remote nozzle that is connected to pipe 80. So now let's size the pump. We turn on GSC. We set the GSC variable and goal using the remote nozzle G51 that has connecting pipe P80 to a pressure of 1.4. So the variable would be the pressure in the pump that is located, as we saw, at junction 707, and we set it for the pipe 80 that is connected to the remote nozzle, the require of the pressure of 1.41. We run the model. So repeating the procedure, we go to analysis. We turn on GSC, so we tell it to use it. We go to analysis tool. We go to analysis setup. We go to goal C control. And first we set the variables. The variables would be the pressure. We want GSC to vary the pressure in the pump, which is located at junction 707. To meet the goal that is a requirement for the remote nozzle of 1.41 bars G, the connecting pipe for the remote nozzle would be P80, as we found in the previous step. We run the model. We go to output. We view the results on GSC to see the size of the pump. So the size of the pump is required 4.697 bar G for the pump to meet the pressure in the remote nozzle of 1.41 bar G. But we have to make sure, we have to check the results to make sure that the minimum flow is above 37.87. That is the requirement for the nozzle G located in junction G51. So if we check it, like the results, we'll see 51 has 47.28 of flow rate, which is much higher than the minimum required. So with this information, we're ready to prepare the NFPA report. So let's go through it again. We see the size of the pump, the size of the pump, as I said, is the pump is located in junction 707 and has a minimum of, it has a pressure required to meet the requirements of the remote nozzle of 4.697 bar G to meet the goals of 1.41 in the remote nozzle, which has a connecting pipe of 80. But we have to check that junction, junction 51 has a minimum required of 37 gallons per minute. So to do this, we collapse this section and we go to junctions, we go to spray discharge, and the requirement for the spray, the remote nozzle located in junction 51 is 37.7, and we see that we have a flow of 47, which is 10 liters per minute higher, which tells us we're okay with the size in that pump. So with this, we conclude our description of two methods. Now we move on to the question sensor. Is there any questions? Well, apparently there's no questions. Maybe you'll have them later. I hope you enjoy this webinar. What's next? You will receive an email follow-up with the link of the recorded webinar. You can join us in future webinars at AFT Learning Center webinars, upcoming webinars. You can request an evaluation at sales.aft.com if you want an evaluation of GSC goal seek control just send us an email. For pricing information, use USA's POTUS in a webpage, and international, contact your local channel partner. Thank you very much for joining us. It's been a pleasure being with you. Hope you have a nice day or night, depending on what part of the world you are at. My name is Ronaldo Pinto, and thank you for joining us today.